We ready? Yes. Ladies, you ready? All right, just grabbing my colors. Okay, so we're talking about sodium being burnt in fluorine gas, which is a faint yellow color, and then a white color forms. So, first thing is we need to look at our resource sheet, and I'm very mindful that Ms. Falsolo emailed me saying there was some stuff missing, which I thought I had gotten everything, but apparently not. So when we're looking at our resource sheet here, we're looking for sodium, and we see that sodium, the metal, is over here. Metal silver, which matches what we have here. Shiny gray metal, same difference, silver, gray. And then we're also looking for fluorine, which is F2, which is over here. Pale yellow gas. Are you okay with that so far? Then you would have looked to see, okay, white powder, and this is where I think a lot of you guys got confused, and that is my bad for not emphasizing it. Everything that I've given you here is either in the solid form or in the aqueous form. Sorry, I should say. Let me backtrack. The stuff that I've given you is in different states. One of the things that I'm very mindful of is that I gave you all the ions in the aqueous state. So when I say aqueous state, I mean if it's dissolved into solution, what color would it be? Because for a lot of situations, you're mixing things together as solutions. The problem is that in this example, you are actually forming an ionic compound that is a solid, and it's a white powder, and some of you guys got thrown off by that. I did try to add a little note here to help kind of cover that question. Some of you guys saw it, some of you guys didn't. It's okay. Something to keep in mind is that if you had these two ions together, so you had a cation and an anion coming together, they would then form an ionic compound. Usually the color would then depend on if you have a colored ion. So say, for example, the chromium ion is green. Copper is actually a better example. Copper is blue. And so that color will translate into the solid ionic form. If you have two ions that are colorless, then you would end up with a white powder. So most ionic compounds are white powders, and that's where you should have gotten that observation. So that was my bad for not clarifying and pointing out this note that I put. The reason why I did that was because there wasn't a whole lot of space, and I didn't want to add another line or to add more detail, being like colorless and aqueous, colored in a solid, because I just felt like it was, or white in a solid. I feel like that was just going to be too much noise. So I was hoping that note would be enough, but apparently not, which is fine. Are we okay with that? All right. The next thing was to then figure out the oxidation and reduction reaction. So you had fluorine going to fluoride over here. So that should have been one of your products. And the sodium metal going to the sodium ion. That would have been the other of the two products. All right. For the oxidation reaction, the main thing that people made a mistake on is you should have shown that you had Na going to Na plus. If you wrote 2 plus, I could not take it because that's the wrong charge for the ion. So that's why a lot of you guys may not have gotten your points. And the thing is, it was on the piece of paper. So really no excuse there. The other one was the fluorine to fluoride. I was looking for F2 becoming F minus. Again, if you forgot the 2 at the bottom here, that would have been marked incorrect because it's fluorine gas. It also would have been marked incorrect if you had a 2 minus, because this is just fluoride minus 1. So all these things are really important in the chemistry language. That would have been the reason why you would have lost out. And that was basically the main barrier for people getting to the achieved level. I saw one person actually flip these the wrong way around. And if you flip them the wrong way around, then it's an automatic not achieved because you don't know how to classify oxidation and reduction. So if the fluorine pair was over here or the sodium pair was over here, that would have been marked as not achieved. If you had flipped these around and you had the charged ions on this side and the elements on that side, again, that would have been marked as wrong too. So that was the main barrier. Most of you guys were fine with defining oxidation and reduction. The merit requirements was another place where people kind of fell down a little bit, and that was more so my fault than your fault. What I was looking for is understanding that, the different things that are happening. So here's the marking schedule so you can see it. So correct linkage, we were looking at the sodium, which is a gray metal, or you can write silver metal, is burnt in fluorine gas, which is a pale yellow. The white powder that is being formed is sodium fluoride. So that's what I was looking at for that answer. If you just wrote that the fluoride was white, but you forgot the sodium, sorry, the fluoride ion was white and you forgot the sodium, then that's going to be marked as incorrect because it's the pair that is white. It's not the individual ions themselves, because you can't have these ions exist individually because they wouldn't be stable. You need to have that positive and negative mixture. It ties back into the ionic compounds that we talked about back in term 1. You have to have a positive and negative. Are we okay with that so far? All right. Next thing then was our explaining oxidation and reduction. The thing with this is I was looking for really specific kind of careful answers. So in this case, identifying that the sodium atom is gaining 1 electron, forming the sodium ion. Some of you guys might have made a mistake by saying 2 electrons or something silly like that. So that would have been the reason why I didn't get that point. Very, very clear what's happening. This one here was more so where most people fell down because they didn't remember to talk about it as each fluorine atom. A lot of people just wrote F2 in their answer and then wrote their answer. It's not that. It is each fluorine in F2 is what I was looking for. Gains 1 electron to form F minus. All right, so some of you guys just made a little error there. Each fluorine, that's what the F is standing for, in F2 gains 1 electron to form F minus. So some of you guys wrote F2 gains 1 electron to form F minus, couldn't accept it. Because it's not. And then some of you guys wrote F2 gains 2 electrons to form F1, and again, it's not the correct chemistry language. So it is quite nitpicky assessment. It's an easy assessment, but it's nitpicky. That's the trade-off. Are we okay with that? Let me know if you need more Post-its. All right, keep going. Okay. This half equation, again, it is just the Na plus 1 electron, because that's 1 electron being lost. Most people got this. If you got it wrong, you did something weird like put 2 electrons, because I think you were starting to try to balance it as a full equation, and you were doing some weird stuff. So let me finish that, and then I'll balance it fully. The fluorine one, again, I was looking for F2, 2F minus, and then 2 electrons on that side. So the errors that I saw happening were people forgot to put the 2 in front of the fluoride, or they just did that, and they've just were missing the other fluorine atom. In the equation, it wasn't balanced. You got to check to make sure everyone's there. So just silly things like that. That was the main issue. And again, this is a really nitpicky assessment. Let me show you guys the marking schedule so we understand. So half equations, both of them need to be correct for the merit, which is the pain in the butt. So a lot of you guys missed out on that. Some of you guys missed out on the merit because of the observations. Some of you guys missed out on the merit because you made a mistake on one of these 2 justifications. So either this one or this one. So it's an all or nothing kind of thing, unfortunately. Cool. And then excellence was putting the full equations together. So this is where people got wonky. They were trying to put these 2 equations together, and they're just like, oh, 2 electrons, and these guys need 2 electrons. And then they're like, cool, my equation's done. And then they started smashing things together. You can't just chuck a 2 in front of here. You have to multiply the whole thing by 2. So that should be a 2 and that should be a 2 when you start putting things together. So the electrons cancel out. So full equation should have been 2Na plus F2 makes, you could have written that, and I would have accepted it as an answer. I would have also accepted this as an answer, because that's also correct. Because all you're doing is just adding the ions together to make the ionic compound. So that is also correct. Be mindful with, I know you guys were doing the other equations. So let me just grab my stuff. See it. Oh no, I didn't do it on this guy. Okay, I'll point it out on this guy just because it's a good reminder. So you guys remember how we added magnesium into hydrochloric acid, or sorry, sulfuric acid? We ignored the sulfate when we're doing the half equations, and when we put it together, we also ignore it. So in this one, your full equation, which I don't think I ever wrote down for you guys, this is 2 and 2, it's already balanced. So it would be Mg plus 2H ions forming Mg2 plus H2. Is how that full equation would look like. It's already set to balance because these two cancel out. So even though this example here with the sulfuric acid is involved, you don't actually have sulfuric acid in the equation at all because it's just a spectator. It's just like when you guys were doing ion identification and there were spectators and you just excluded them. No point. They're not involved. Okay? In fact, you're making it worse because then you have to balance them. Are we okay with that? Okay. This was the other chance for you guys to show me as a backup option, because if you look at the merit requirement, it says links oxidation to correct number of electron transfer or oxidation number. So this is another chance to have a backup for either of these two in case you make a mistake up here. So it is technically a merit, but I do put it in the excellence section just because, you know, I don't know, distinguish it so it doesn't confuse you guys. So for example, with the oxidation number here, I would say sodium has an oxidation number of 0 in the element form. When oxidized, the ON increases by 1, making Na plus oxidation number +1. Be mindful that when you guys are writing oxidation number, the positive and negative goes before the number. When you're talking about charge, it goes after the number. So that's something I will look for the excellence to make sure you know your chemistry language. In this case, because of that fluorine being that weird double for the molecule, the atom in the elemental form has an ON of 0. When reduced, it decreases by 1, making F minus ON -1. So just 2 chances to show the same information. Questions, concerns, or comments? All right, I'll leave that up so you guys can copy that. So it's not a hard assessment, but it is a very nitpicky assessment, unfortunately. So you do have to dot your I's and cross your T's. Or check to make sure your positive and negative signs are in the right spot. And make sure you're talking about each. Cool. Feeling a bit better? All right, so I will give you a similar level of difficulty question because I don't believe in giving you the hard ones because the assessment doesn't require me to do that. Like I said, I put onto Google Classroom. Can I move it? Yes. Okay. I put onto actually say my Google site. Actually, I'll go through the Mahi choice. How about that? All right. So, here's the feedback lesson. So, Mahi choice for today for how you want to use the remainder of this session. First option is you can continue doing practice questions that were listed in question number 2. These are going to be the same level of difficulty that I'll give you on the second and third attempt. So click on it, and then you have a whole list down here that you guys can do. This is basically the level of difficulty that you'll be looking at. So metals that are added to acid or stuff being burnt. In fact, that was the assessment question. Huh. And then if you want to aim for top scholar, I recommend doing the SciPad pages on oxidation numbers because it does go over the other types of questions I will ask because there are some complicated balancing ones. If you go to lesson number 3, that's where I state what pages to do, and I also provide you those complicated questions. So you'll see in these questions here, like permanganate, I'm adding things in there that have an oxygen. So you have to think about how do you balance the oxygen, how do you figure out oxidation numbers when you have those complicated ions. So FYI, that's there as well when you feel ready for it. And then last option for today is you can work on your titration internal and just get that polished off. Cool. So second attempt will be on Thursday because I don't think it's that much to ask as an assessment. Third attempt, if you guys do need it, will be during senior assessment week. We can do that during our workshop. And then top scholar, I'll give you that question in term 4. Okay? Cool. Yes.
On Friday,
And you can make it up on Friday. So Friday, I will pick back up structure and bonding, and I will record the lesson so you can just watch it. Yeah, hoping we won't have too many absences. We've been very badly hit by absences. All right, cool. That's us.